Here is the last type of pericyclic reaction we call sigmatropic rearrangement. Okay. All right. Just start with the definition. So tropos, like from tropic, tropos in Greek means change. It's a change of sigma bond, so sigmatropic. Okay. So this reaction is a rearrangement of a sigma bond. All right. So one sigma bond break right here, I label in red, and then the other one is formed. All right. Now the first one right here. So when you draw the reaction mechanism, so you can start from any bond, right? But I'm gonna show you right here. I'm gonna move the double bond right here to the left side, break this sigma bond, put the 2 electrons down as a double bond down here, and then push this double bond to form a sigma bond. Okay. So break one sigma bond and then form another sigma bond. Now all reaction must have a driving force, so it can go forward, right? We'll talk about driving force in the next video, all right? But right now, just be familiar with the overall of the reaction. So we break one sigma bond and then form sigma bond at a different location. We have a little bit nomenclature. This is how we call it. We call 3, 3. We call 3, 3 sigmatropic rearrangement. Do not do 3 plus 3. The 3 plus 3 means cycloaddition. We have to use comma. That's only different. Okay. The 3 and 3 right here signify the number of atoms between the bond that's being broken, and the bond is being formed. Take a look. We have 1, 2, 3, and then 1, 2, 3. All right. So look at the bond being formed and bond being broken. How many atoms are between those bonds? Okay. We also have a 1, 5 as an example. I'll take a look. The bond gonna break right here, the red one right here. So draw the mechanism. Put from a sigma bond with a hydrogen, break the red bonds, that sigma bond, from double bond down here between carbon 1 and 2. Move the double bond between 2 and 3 to 3 and 4. Okay, look like a cyclic compound. All right. So and then form bond on the right side right here. Basically, bond breaking, bond forming. How many atoms are like between this bond? We have 1 to the hydrogen, right? And the other group, they have 1, 2, 3, 4, 5. We call 1, 5. Start with the lowest number, right? 3, 3, 2, 3, 1, 5, 2, 4, something like that. Okay. All right. This is sigmatropic rearrangement. There are 2 name reaction, which means like they have the name for it. For sigmatropic rearrangement, let's talk about this in the next video, and we're gonna talk about the driving forces as well.